a chi-squared, and it's a chi-squared goodness fit. We can see it's not a two-way table. We can see that it's not a t-test. If it was a t-test, we'd have two groups of data, and if it was a two-way table, we'd have a two-way table. And therefore, if we're doing any sort of statistical test, which we can see we are looking down, then it must be a goodness of fit. So for this question, a dice is thrown 120 times and the results have been recorded. So these are the answers from 1 to 6 that we could have got on the dice, and the results were 27 number 1s, 12 number 2s, 16 number 3s, and so on. So what is the expected frequency of throwing a 2? Well, the expected frequency, if we threw it 120 times, would just be 120 divided by the 6 times that I threw it. So we would imagine an equal number each time. So we can go to our calculator here and we can do 120 divided by 6. So we would expect 20 times on each number. So I'm just going to add here the expected values would be 20, 20, 20, 20, 20, and 20. So for 2 marks there, one of them is for showing some sort of working and one of them is then for the answer. So the second part of the question is that we need to show all of the steps clearly and test whether or not it's fair, and we're testing it at a 5% significance level. So as we talked about earlier, we know that it's a goodness of fit test because it doesn't fit into either a t-test or a chi-squared independence or two-way table. So that means it must be a goodness of fit. So if we're asked to show all steps clearly, that means we're going to go through the full kind of test that we would normally do. So the first thing we need to do is write down what we expect the null and the alternate hypothesis to be. And we know that we have to state a hypothesis before we can do a test. So the null hypothesis is that the dice, or the values that it can land on, is fair and therefore fits into a uniform distribution. Okay, so the dice is fair or you can say follows a uniform distribution. Okay, and the alternate hypothesis, HA or H1, is that the dice is not fair. Or doesn't follow a uniform distribution. Okay, and once we've done that, we're now going to move on to the next part of our hypothesis testing. And we now need to make sure that we're typing into our calculator the expected and the observed values. So we're going to go to the statistics and edit, clear anything that you have in there, and we want to we need to write down the observed values. So the observed are this column or this row here, which are the frequencies that we observed in our experiment. So we have 27, we have 12, 16, 25, 26, and 14. And then the observed is 20 for each of these numbers. So we would expect to see 20. So we're kind of comparing and saying, are they different enough, or is it what we would expect to see? So we can now go into statistics, tests, and it is a chi-squared goodness of fit, which is this option here, option D. The observed is this one here, and I put this one in first. So this is column 1. And then the expected, the 20-20-20, is the L2 that I put in second. I always need to change the degrees of freedom. So don't forget the degrees of freedom there. So the degrees of freedom are 1 less than the number of data pieces we have. So it's 6 minus 1, which is therefore 5. So I'm going to change the degrees of freedom. Oops. And then we're going to calculate. And we can see that we have a chi-squared value, which is 11.3. And we can see that we have a p-value, which is 0.0457. So they're my values. And I was testing it at here it is, 5% significance level. So if we draw kind of a diagram of what we've found here, this is my chi-squared distribution. So I was testing it at a 5% significance level, and the p-value I have is 0.0457, which is approximately equal to 4.57%. So mine is actually less than that, this point here, which is 4.57%, so it's slightly less. Now the significance level, the 5%, is what tells me whether I take the alternate or the null hypothesis. So if my area is less, it's kind of this point here, that's suggesting that I'm in the alternate hypothesis. And you can also just remember our usual kind of fact, which is that when the p-value is too small, it's less than the significance level, therefore we reject the null hypothesis and we accept the alternate hypothesis. So that's then the conclusion to my test. So the conclusion is that the dice is not fair. It does not follow a uniform distribution, and actually there might be something up with this dice.